Thank you for joining today's webinar on BACnet Basics. Today we'll take a look at BACnet from a VFD's perspective. I'm Tim Skell, Application Engineering Manager. A little bit about myself. Been working with drives for over 20 years. The past 10 plus has been with ABB. I'm based out in New Berlin, Wisconsin, where the ABB VFD manufacturing facility is, where we're building and packaging drives. The most of my experience for drives is on the HVAC side, although I've worked in the water and wastewater and industrial side also. I'm very active in the BACnet community. I participate in the BACnet International Marketing Committee. I've had several articles published in the BACnet Journal. I present education sessions on behalf of BACnet International, and I'm a past winner of the BACnet Member of the Year Award. Usually I don't bother getting into those level of details on the BACnet side, but since today's presentation is on BACnet, I figured I'd bring it up just so you can have some degree of confidence. I do know how to spell BACnet correctly, and I am familiar with the concept. From the schooling aspect, my background is on the electrical engineering side. For today's agenda, what we're going to do is start with a building automation system, just a real basic overview on the building automation system, and then we'll get into BACnet itself, and we'll talk about the information that BACnet can provide. And right at the end, we'll just show you how easy it is to set up a device, and we'll use a VFD as an example for BACnet, along with some troubleshooting tips for some of the technicians that may be on the call. So this overall presentation, we're not going to do a real deep dive on the ones and zeros of BACnet. That's not really my intent here. Today we want to kind of do an introduction. Somebody who is not overly familiar with BACnet, they want to kind of get their feet a little bit wet, learn about BACnet, and then I'll dabble just a little bit onto some of those technical things for the people that are the technicians, or whether it's a VFD startup tech, whether it's a controls engineer who's getting into it. Well, we'll touch on a few things that'll be good for you, but overall, I'm going to keep everything a little bit higher level for this particular presentation. So looking at a building automation system. So BAS, building automation system, BMS, building management system, tomato, they mean the same thing. So we're going to start at the high level. So you've got, as you look at that image on the right, you got at the top there, you got your operator workstation. So that is basically, you can view that as your computer screen. It's your interface into your building's HVAC system. And that's set up typically by your controls contractor. And then that is going to be talking BACnet to a building controller, which is also provided by the controls contractor. That's kind of that higher level brains that's kind of controlling your system's HVAC. And then that device is also talking BACnet to smaller controllers that are a little bit closer to the application. So I'll call them an application specific controller. Perhaps that's a controller that's mounted right in an air handler, and it controls how that air handler operates. And then that device we'll be talking to a drive. Perhaps that drive is on a supply fan of that air handler. So it's out there controlling how fast that drive is running, monitoring that drive status, making sure that we're making appropriate flow out of that air handler and maintaining duct static pressure. So application specific controllers, that's typically provided either by the controls contractor, sometimes the OEM equipment. The VFD, that's typically provided by the local VFD representative, or sometimes part of the OEM equipment. But you'll notice as we start at the top of that image and work our way down, there's basically BACnet. It's allowing all these devices to talk to each other. And we'll get into that. And then when you get down to the application-specific controller and you look at that drive there in the bottom right, there's a lot of different ways you can control drives and devices like drives. And the old way of doing it, and we'll get into it in a little bit, is using analog signals and start-stop, just on-off type signals. You can also do that all over BACnet too, or you can have some mix of that control over BACnet. So we'll get into that in a little bit. So going into that building automation system and just walking through the concept of a BAS or BMS. So I'm going to use the building I'm based out of as an example. So I mentioned earlier I'm in New Berlin, Wisconsin, so a suburb of Milwaukee, and this is essentially our building. It's a mix of production floor space and office space. So when you see all those colors on the right side of the image, those are all different zones within an office. So each one of those zones has a VAV box that's feeding it. There's a thermostat there to control that specific zone. And then that dark area in the middle, that's the production floor. We don't have that all color coded. You'll also see that there's references to AHU, air handler units, 1, 2, 3, all the way up to 7. So those are all the different air handler units that feed the area. So air handler 1 in the top right that feeds half the offices. Air handler 2 down in the bottom right, that feeds the other half of the offices. And we have a bunch of air handlers up on the roof there to feed the factory. So I can see very quickly exactly what the conditions are. So green means it's hitting the target that we want to hit for temperature. Yellow means it's almost hitting that target, it's just a little bit off. Blue means it's hitting that target and it's a little bit off, but it's a little bit cooler than intended. And orange would be it's a little bit warmer. So for example, in the bottom right there, you see that orange, that happens in the mechanical room. Yeah, as much as I'd like my mechanical room to always be at 75 degrees, it usually runs a little bit warmer than that. What I can do then within my building automation system, I can tunnel down. So the previous screen was kind of the status of the building. Now I can also look at the system status itself. So the image on the right here is of my chilled water system. So I've got my chiller, I can see what its capacity is running at right now. I can see my chilled water pumps. I have a N+1 system, meaning I have a backup. So I can see which of my 2 chilled water pumps are running. I can see how fast it's running. I can see if it's faulted or normal status. I can see my pressure 2/3 of the way down the piping. So this is all excellent information I can see. And oh, by the way, all of this is possible because of BACnet, because all those data points are coming back to the building automation system and my operator workstation where I can see all this because of that BACnet communication. This is really, really helpful when I want to do things like remote troubleshooting, because now I don't even have to be in front of the piece of equipment. I can troubleshoot and figure out what's going on before I even walk out to look at the equipment. I can look at pieces of individual equipment in my building automation system. So I mentioned earlier air handler 1, that's feeding half of the office space. So here I can see my overall view of my air handler. I can see my supply fan. I can see my return fan. I can see that my supply fan is on. I can see it's been commanded at 31 Hertz. I can see that it's actually running at 31 Hertz. I can see it's drawing 2.2 kilowatts of power. I can see it's not faulted. I can take a look at my chilled water and hot water coils. I can see all my alarms are off, so I don't have any free smoke or high static issues going on right now. I can see my duct static pressure set point and what I'm actually maintaining at this very moment. So there's just incredible amount of information here. And again, this is excellent for remote troubleshooting. The other really neat thing you can do, and this is where BACnet again comes in, is I can trend a lot of data. So all this information is available within the VFD, again using the VFD as an example. So for example, looking at how much power the drive is drawing over the course of a day, I can trend that and use BACnet to pull that data and log it in my building automation system. So it's really cool because now I can see exactly where my power is being used within my building. And oh, by the way, this is essentially free within the drive. I mean, this information is in the drive. All you have to do is up front have the controls contractor have that point of data brought up to the building automation system, pay that small charge up front for that labor for them to do that, and then you will have that information readily available. Tell you what, it's a heck of a lot cheaper than buying a bunch of power meters and sticking them all over your building. Just use the data that's on the drive, leverage BACnet to get that data out of the drive. Mentioned earlier when we were looking at the overview, we could see individual zones. So here's a VAV box, so I can see how open it is, what the air temperature is coming in and out. So we're not heating right now, so the entering and exit air is approximately the same. I can see my thermostat there. Heck, if I wanted to, let's say I've got somebody who likes to go over there and manually turn that up, I can remotely turn it back down or vice versa. So I can do that. I can control what my heating and cooling set points are on that thermostat. So I can do this all remotely via my building automation system. All this logic is being done via BACnet as far as the communication to get this information from one piece of equipment to the other. So now what I'll do is dive a little bit into BACnet, because what I wanted to do initially is, for those of you who aren't familiar with building automation systems, I just want to spend a little bit of time showing you what a BMS system really is capable of and what it is. So now let's talk about BACnet itself. So what is BACnet? BACnet is a communication protocol. So it allows all these different devices to talk to each other. So the best analogy I can give you is just look at us as humans. Today, I'm talking in English to you. So as long as all of us here are English speakers, we can all communicate appropriately with each other. ASHRAE itself, there's an ASHRAE standard 135, that is the BACnet standard. So what ended up happening is in the past, there was all these different proprietary communication protocols. And what that really did is it made it hard to have all these different competitive devices talk to each other. You basically had to settle on a certain brand and use that for your automation system. So the industry said, you know what, that's not acceptable. We need, it doesn't matter if it's an ABB drive, I'll use drives as an example, Danfoss, Yaskawa, Eaton, Delta, pick any of the 15 drive manufacturers. Shouldn't matter what drive it is, shouldn't matter what controls person it is, whether it's Honeywell, Johnson Controls, ALC, Allerton, Cylon, any of those manufacturers, they should be able to talk to each other also. So what they did is they came up with BACnet, which allows that common language for all these different devices to talk to each other. And BACnet sets that standard for how does that protocol work. So there's BTL, BACnet Testing Labs, and that's what we will do is take products and send them to be certified to make sure that we're talking BACnet correctly. So that way somebody doesn't just say, well, I have BACnet, didn't actually get it BTL certified. You don't know if it's really communicating BACnet correctly. And then there's something called PICs. So again, I'm just not to do a deep dive on this, just kind of giving a general overview of some of the things you might hear of in BACnet. Protocol, implementation, conformance statement, and it really talks about what portions of BACnet are implemented in a particular product, and I'll show you an example of that later. So why choose BACnet in the first place? Well, I just talked about it's an open protocol. It's that English-speaking language, the one that we're all talking today, so any vendor can be used. It allows all those competitive devices to be able to share a single wire and talk to each other. So going back to those old days, when there were proprietary controls, if I settled on brand X as my building automation control system, all of my main equipment that was going to be communicating to each other also had to be brand X. So let's say, for example, I had a thermostat fail that should have been a $500 all-in replacement with labor and everything, but I'm pretty much locked into brand X. They could charge me $3,000 for that thermostat, and nothing I could do about it because I'm locked into brand X. And if I wanted to change out, I had to gut out my entire automation system. So that's how it was in the old days with these proprietary protocols. There's still some floating around out there. Some of it is a little bit more in the legacy buildings, but you still see some of it in some new designs. But for the most part, if you're specifying a building, or if you're in a position to be able to make recommendations for something, definitely recommend BACnet. It is the open protocol that everybody can speak in HVAC. So a little bit about ABB's history in BACnet. Again, background to give you a little bit of degree of confidence that I and ABB know what we're talking about when it comes to BACnet. ABB was a legit pioneer when it comes to BACnet. We were the first VFD out there to have BACnet certified. So we identified BACnet when the concept was coming about, and we really jumped on that bandwagon because we knew that was the future. So that first drive to be certified with BACnet was the ACH580, and that was done by Symmetrics in 2004. That was before BTL, BACnet Testing Labs, even existed, because I mentioned previously that today, if you got a product and you say, hey, it speaks BACnet, one of the things you do is you send it off to the BTL lab and they'll certify it. We had BACnet before there was even a BTL lab. We also participated in the first ever BACnet International Interoperability event, now known as PlugFest. So that's where you get a bunch of folks together from different manufacturers and basically start sharing a wire in a lab, and we start communicating with each other, and we start trying new features out and things like that to make sure that they all kind of essentially play nice with each other. So that first one was in 2005, so we were part of that first ever PlugFest. Now, if you looked really closely at some of the previous pictures where I had BACnet reference from the operator workstation to the building controller to application-specific controller, sometimes I had BACnet MSTP listed, sometimes I had BACnet IP listed. So we'll take a moment to kind of talk about what that really means. So ultimately, there are two flavors of methods to run wire for BACnet. One is considered a twisted pair. In the case of a drive or an isolated device, it's a twisted pair and reference wire. Typically, it's shielded. That is your MSTP, Master Slave Token Passing, is what MSTP stands for. MSTP, it's usually used at the end device level, so VFDs, a really smart sensor, those type of a thing, something where there's good information there, but it's not critical that that information is provided incredibly fast or a large amount of that information. MSTP is inherently a little bit slower in how it can transfer that information compared to IP. MSTP is definitely a lower cost to install, doesn't have any coordination required with the IT department. So that's why you'll see MSTP, that twisted pair and a reference wire, and most likely it should be shielded, as the typical wiring for your end devices, your components at the very end closest to the application. In the case of drives, BACnet MSTP is embedded in pretty much any HVAC VFD out there. Your other type is IP. So you can kind of think of IP as your Cat5 cable, or some even might consider your Ethernet cable, the one you stick into the back of your laptop when you need to hardwire into your internet connection. That's the other type of BACnet hardware cabling that can be used between devices. On the right, for example, that picture is of a BACnet IP card that plugs into a drive. So in that case, it happens to be an ACH580 drive, ABB drive. So if I wanted BACnet MSTP, the standard drive has it embedded. If I wanted BACnet IP communications, you get that plugging card, snap into the drive, and now it can talk BACnet IP. So we're slowly seeing more BACnet IP being used at the end device level like drives, but we're still mostly seeing MSTP. But IP is gaining popularity there. It's definitely a faster rate of transfer of information. It's more resilient to noise. It's a little bit higher cost up front. You got to coordinate with your IT department. So the cost aspect in HVAC, where a lot of times you're trying to keep that cost as low as absolutely possible, kind of slows down that adoption of having BACnet IP at the drive level. But again, MSTP and IP is just two different ways for the BACnet to get to different products. Different wiring methods are being used. I mentioned earlier that I'm not going to do a deep dive on the technical aspects of BACnet in this presentation, but I was going to give a couple tips for some of those new VFD technicians or controls technicians. So here's a quick handful of tips on the BACnet MSTP side. These are things I've kind of learned through the years, the school of hard knocks. I've learned it the hard way. So hopefully you won't need to learn it the hard way, the way I've learned some of these things. So first off, BACnet MSTP, that wire should be shielded. Drives, they create a lot of electrical noise. That's just kind of how drives work in general. They're switching 650 volts DC on and off 4,000 times a second. It puts noise out there, so use shielded cables. Usually I would not recommend ever landing the shield at the drive. Basically, you keep the shield maintained, so when you have to cut that wire to land at the drive, you basically twist it and tape back the shield and keep it maintained. Make sure all your BACnet wire is routed, which is low voltage wire, is routed away from input power and motor cables. That one should be common sense, but sometimes we get in these installations, there's not a whole lot of room, and you got to get kind of creative. So again, try to keep your BACnet wires away from your higher voltage wires, especially any kind of motor cables. Twisted pair is not enough for VFDs. A lot of times in BACnet, for real simple devices, they'll just run a twisted pair, or basically a positive and negative. With VFDs, because of there being an isolated device and they create noise, you want to have a reference wire. Most of the time when I see noise-related problems with BACnet and drives, it's because they did not run a reference wire. So some controllers don't even have a point for the reference, so like whatever the building automation controller is. So if you ran into that situation, you check with the tech support at that control manufacturer, and they could probably give you a point that's not necessarily labeled as the reference on their controller, but they can tell you what that point would be. And then lastly, as BACnet was coming out, if we flash back over 10 years ago, they actually updated the standard to recommend that if you've got an isolated device such as a drive, that you do run a third wire. And then if you can't run a third wire, they've got some other recommendations on how you can do some grounding practices. Every once in a while you'll run into somebody that says, oh, BACnet, I have problems with it. Well, usually it's because they had a poor installation. It's either because of how they physically wired it or how they implemented BACnet on the programming side. A properly implemented and wired system in BACnet is quite robust. Some additional tips for the technician. There's end-of-line resistors. So the end devices should have an end-of-line resistor. Usually the controller is one device that's on the end of the line, and then if it happened to be a drive on the other end, you put the end-of-line resistor there. There's actually a switch that you can flip on in an ACH580 drive to put that termination there. There's biasing. Typically that's done by the controller. That's basically providing voltage, pull-up voltage to the wire. Most folks now are biasing the wire in the controller itself, but I've seen some older Siemens hardware that was based on their old FLN systems, and that hardware doesn't bias the entire wire. So if you end up with one of those systems and you start seeing products on that BACnet wire dropping off, and hey, it works fine with 2 or 3 devices on that wire, but I put 4 or 5 devices on the wire and then they disappear, there's a good chance there might be a biasing issue if it's some of those older hardware designs. So again, there's a dip switch on, say, the ACH580 drive that you can flip to bias the wire. Baud, that's how fast the devices are talking to each other. So everything on that wire should be talking at the same speed, because if I'm talking really slow like this, and then somebody else is talking really fast like this, and you got all these devices talking at different speeds, it just isn't going to work, and it's going to crash the wire. So there's specific speeds within BACnet that are standard that you can choose. So there's parameters within the drive that you select, hey, this is the speed I'm going to run at. There's even auto baud detection in a lot of devices, like say the ACH580, where it figures out what speed the wire's already talking, and then it goes ahead and talks at that speed. It doesn't even require the technician to put in that setting. And the last thing to mention here is on the ID side of things. BACnet, you basically got 2 different IDs. So we all have our names. So in the real world, I got my first name, I got my last name. So my name again is Tim. So in BACnet, we end up labeling all of the devices and giving them a name. So there's a MAC ID name and a device object instance ID name. MAC ID has to be unique on that wire, and a device object instance ID has to be unique on the entire network. So a lot of times when there's some early issues going on during startup, it may be because there's 2 devices that are called the same thing. So when the controller says, hey, device number 5, MAC ID 5, what is this information? And all of a sudden you got 2 devices trying to answer that. Obviously you're going to run into problems. The next topic is a strategy conversation, strategy topic. I like to joke around and say it's to monitor and or control. That is the question. So what I'm talking about here is, how much BACnet do I really want to use or leverage in my system design? Before there was BACnet, everything was hardwired with analog signals and relay signals going to a drive and from a drive. So I might have a couple analog signals going into the drive, so it's maybe a 0 to 10 volt to control speed as an example. And I might have an analog signal out of the drive going back to the building automation system to let the building automation system know what speed I was really running at. I could have relay outputs going to the drive for start-stop, relay outputs from the drive to the building controller saying, hey, am I running? Am I faulted? Is the belt broken? Those type of things. But there's only so much information you can do back and forth in those old systems, because it would get really, really pricey with the amount of I/O and the amount of wiring that had to be used. So that's where the BACnet really comes in, and there's the beauty of BACnet. So there's 2 ways I see people implementing BACnet. One is they still use the hardwire, those relay outputs and those analogs for the most critical things like your start, stop, and speed control. And then they use BACnet for the monitoring. So things like how much power is being consumed, what's the current draw of the motor, those type of things are all over BACnet. So that's one approach. The other approach is to use BACnet for everything. So now if you wanted to give it a start-stop command, that's over BACnet. You want to know how fast it's running, that's over BACnet. Everything goes over BACnet. Traditionally, folks will lean a little bit more towards the hardwire control of BACnet monitoring as the go-to, just because they view that as a little bit more robust, because if the BACnet wire went down, they still had their start, stop, and speed control. If you look at it from the BACnet controlling of everything, really what's important in that case is to make sure that you design a system where if the BACnet wire did go down, that the drive is able to continue to do what it needs to do for that application, whether that's moving the PID loop into the drive in the first place, or it's programming the drive to run at the last known good signal, or speed command over BACnet if it lost its speed command over BACnet. Those are all things that can be done. Usually it's a little bit lower cost to have BACnet do everything, so that's one reason why we're starting to see a little bit more of that, is just now you don't have to run all those analog wires, relay output wires back and forth. You don't have to use up any I/O on the controller. Upstream, the building controller, everything can just be done over BACnet. So that's why we're starting to see a slow trend towards using BACnet to do control and monitoring, but still the most common install is hardwire with BACnet for monitoring. One thing I always like to mention whenever I can, and especially for you VFD startup technicians and you controls contractors and control engineers up listening right now, is always run the safeties back to the VFD. Doesn't matter how you're doing your BACnet control, BACnet monitoring, hardware control. I don't care how you're doing it. Safeties should always go back to the VFD. Why is that? Because I want the safety to still work in hand mode. I've seen too many installations where they run the safeties back to the building automation system, and then the building automation system just gives the drive a stop command if the safety opened up. Well, guess what? If that's a high static safety and there was an issue and it stopped the drive, now you run risk of somebody saying maintenance coming up and saying, you know what, people are complaining that it's too hot. I need to get this drive running. I don't know why it's not running. I'm going to put it in hand and I'm going to force it to run up to full speed. Well, if there was an issue with airflow being blocked, VAVs weren't open, now this is where you end up taking your square or rectangle ductwork, turning it into oval ductwork, or blowing out a seam. So it's very important to run your safeties back to the drive. Next topic is BACnet object types. I'm not going to do a deep dive here. I just want to pull the curtains back a little bit on some of the things going on in BACnet. These next two slides will be a little bit more appropriate for, say, a controls contractor or a VFD startup technician getting into BACnet. But there's these different object types, and the first one on this slide will be analog objects. These mean that there's some sort of variable there, and we're providing a range to explain what that variable is. So as an example for the analog input, let's say I had a VFD on a cooling tower and it's controlling how fast that cooling tower fan is running, and then I had the temperature sensor wired back to the cooling tower. Now, of course, I want the building automation system to still know what the temperature is of that water. So over BACnet, they could read that AI object, maybe that's AI1 as an example, and they can read that and know what that water temperature is. So even though the temperature sensor is wired back to the drive and the drive may even be doing the PID loop, the automation system can still read what that value is, what that temperature is over BACnet. Analog outputs, hey, I could command a VFD's analog output over BACnet if I wanted, kind of a handy get out of jail card if I was short on outputs. Analog values, you'll use those a little bit more in the drive world. So that's a range, again, it's analog, and then it's a status of a variable. So for example, I can read how many amps a motor is drawing from the VFD, or I could read how many kilowatts that motor is drawing from the VFD. So really handy information you can read. Then there are the binary examples. So again, just more objects. So binary is, it's more of a, instead of being a range of information, it's an on or off. It's a yes or a no. So for example, I can monitor the digital inputs on the drive and I can see each of my digital inputs. Is it open or is it closed, on or off? Really handy, for example, if I have, say, a supply fan application, driving a supply fan, I got a high static safety, I got a smoke alarm, and I got a free stat safety all wired into that drive. Yes, I'm in Wisconsin. We have free stats. You don't have to worry about that in southern parts of the U.S. So anyway, one of those three safeties opened up and told the drive to stop. Depending where that equipment is, might mean I have to go up to the roof and really have to go spend 15 minutes to get the darn drive sometimes. But in the case of BACnet, I can do a heck of a lot of troubleshooting remotely, so I could figure out which of those three safeties opened up. If I had them wired into three different digital inputs on the drive, over BACnet to that operator workstation, I can see which of those three digital inputs opened up. So I know immediately it's like, oh, it was my high static safety that opened up. So I can do troubleshooting before I even get there because of this information. I have binary outputs. You can, an example there is I could control the relay output of a drive if I was short an output. Another one was get out of jail cards. Binary values, this is really good for status. So it's a yes or a no or on off. Is my VFD running? Yes or no. Is my VFD faulted? Yes or no. So if you need that information from the drive, automation systems to say, what is the value of BV0? What is the value of BV1? What is the value of BV2? Kind of go through a list of all the different things that we can answer. Then there's multi-state values. It's like a multiple choice. It's a specific, hey, what mode are you in? But instead of being yes or no, it will say, well, I'm in one of four modes. So if I look at the example, I could be a VFD in hand, off, auto, or override mode. So if I was looking at that multi-state value, the drive would respond back and say which of those four modes it is in. So there's just so much information available, and there's just different ways to get that information from the drive over BACnet. If I really want to take a moment and look at what the most important objects are, now there are over 100 different data points that you can monitor in a VFD alone. And now you multiply that by all the different VFDs and all the different pieces of equipment and all the different types of equipment, not just VFDs, but everything else that's talking BACnet. Realistically, it doesn't make sense to look at every one of those pieces of information. Isn't always necessary. Sometimes there's a reason for that piece of information, but what I'm going to do is just spend a little bit of time going over some of those key items. So on the right there, that's just an example of taken out of a manual for a drive. You'd also see something similar in those pick statements. It's that answer key of all the different data points that are there. So the ones on the right there, you can see it in that image. The left column has the object ID, so that's the analog values, just as an example. So if I wanted to read output frequency, I would ask the drive, hey, what's your value of AV1? And the drive would come back and say, hey, I'm running at 45 hertz. So now the building automation system would know that the drive is running at 45 hertz because it asked for the value of AV1. So that's ultimately what BACnet is doing. It's got these answer keys, these tables like this that you ask the drive questions based on your AVs and your BVs and all those different types of objects we just looked at on the previous slides. So some of the most important items to look at: any binary inputs that are tied to the VFD. So I gave the example of that supply fan that might have 3 safeties into it. So if you got any safeties wired to the drive, you should definitely be monitoring those binary inputs on your operator workstation and the controls. Any analog inputs should be monitored if you have external sensors coming to the drive. Binary values should be monitored for knowing if the drive is running, faulted, if it's in a warning mode, if it's ready or not, if set point's been reached. If you want to be able to do fault reset of the drive remotely, you could set that up. If you have belt-driven equipment, you could set up a binary value to know if for the drive to sense if the belt has been broken or not. Analog values, those are those AVs, like up on the right side there. You've got AVs for how fast the drive is running, how much power and current is being consumed. Your DC bus voltage can be really handy for troubleshooting. VFD temperature, kilowatt hours, run hours is great for maintenance. So those are all examples of AV information that you could pull back to the building automation system. And then that multi-state value, those MSVs, those can be good for knowing if you're in handoff or auto mode. I can't tell you how many times I've been on a job site where they've had a problem with how the automation system was controlling the drive and they put it in hand and they just left it there. And if there's no power cycles or anything, it'll just sit there and run at whatever speed forever. And the amount of energy they wasted, it's just mind-boggling sometimes. So I would highly recommend that a building automation system be set up that if somebody was to put a drive in hand mode, that it trigger an alarm. It flips a flag in the operator workstation and say, hey, don't forget this drive is running in hand mode. There might be a really good reason it's in hand mode, but you don't want to leave it in hand mode. So that's where you can put these reminders in the automation system. I could also use a multi-state value to know what fault has occurred. So again, all these great remote troubleshooting techniques are available and leveraged via BACnet. So now a little bit more of the behind the scenes BACnet. So I mentioned earlier BACnet MSTP, master slave token passing. So the best analogy I can give you on this whole token passing aspect of BACnet is back when I was in school, I had to read the Lord of the Flies book. And depending on how old some of you are listening right now, I bet some of you have also had to read that. And if you remember in that book, they had the conch. And that was the way for everybody to have a turn and have their voice be heard. So that's essentially what the token is within BACnet MSTP. It's a conch that's going around the BACnet wire. And when you have the token, you've got the conch, you are allowed to talk. So that's how they keep these wires from crashing, is everybody has their turn to talk. So that's what MSTP is, master slave token passing. You can always consider the token to be the conch if you ever read the Lord of the Flies book. Other items about BACnet, there's the PICs, that protocol implementation conformance statement. I referenced that earlier. It basically tells you what aspects of BACnet a particular product supports. So that happens to be a screenshot of the ACH580 PICs document there. So the multi-state value, that's an example of something you can support. I explained that one in the previous slide. There's also ones like read property multiple. This is where I can ask you multiple questions, opposed to just read property, where I can ask you one question, then you answer me one question, I ask you one question, you answer me one question. Read property multiple is I can ask you 5 questions, and then you got your token, and then you answer 5 questions, 5 answers back to me. So it helps get a lot more information going on that BACnet wire. Same thing with write property multiple. I can tell the VFD multiple things at once. There's COV, change of value. Instead of me continuously asking you for the same information over and over, how fast are you running? 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 And just continuously doing that. Instead, I could say, you know what, VFD? When you change your speed more than 1 hertz, let me know that your speed has been changed by more than 1 hertz. So let's say it had been running at 45 hertz and it's been running at 45 hertz for 20 minutes. All of a sudden, if it goes to 46 hertz, now when it gets a token, it says, hey, by the way, I'm running 46 hertz now. So that way we didn't waste our time continuously asking the same question over and over and over again. You just waited for the drive to trigger its change of value and let you know that it had changed. So these are all things that are going on behind the scenes. It really allows you to optimize the traffic on a BACnet wire. Time synchronization, another really cool feature of BACnet. So I can calibrate all the real-time clocks. So for example, drives have clocks in them. Typical drive, that clock might run 5 minutes fast or slow over the course of the year. So instead of having to reset it every couple of years, you can use the BACnet time sync feature, and BACnet, say at 4 o'clock in the morning every day, can go ahead and calibrate all the clocks on all the different pieces of equipment. It's great for troubleshooting, so that way your clocks are very accurate. So really, again, these are all behind the scenes things just to be aware of if you're, say, a controls engineer, controls contractor getting into it, ways you can really leverage and get a lot of information over the BACnet wire without bogging it down, leverage these services. Now I'm going to take a look just at a real quickly an ACH580. This is an ABB HVAC drive, just to show you how easy it is to set up BACnet from the programming side of things. So I would navigate to communication within the primary settings, hit the right arrow or the select button, either one, go to embedded field bus, go into there, go to communication setup as step 3. Once I go there, and now I'm just to step 4, and I can choose, say, BACnet MSTP as my embedded field bus I want to talk. Go ahead, highlight BACnet MSTP, hit save, and now I'm basically on all the different configuration items on BACnet MSTP. You'll see that baud rate on step 5, that third one down there, is set for auto. So that means the drive will figure out how fast everybody's talking. So everybody's talking really fast like this, or if everybody's talking slow like this, it figures out what that existing baud rate is and aligns to it. And then you can go ahead and that station ID, that's your MAC ID, where it's one number that has to be unique on that wire. And the device object instance ID, which has to be unique on the network. You set your 2 names, and then you scroll down on step 6 there where you apply the settings, hit select there, and boom, you just configured an ABB drive to be able to talk BACnet. And now it's up to the controller to decide what pieces of information it wants to be able to pull from the drive. So it is not difficult at all to set up BACnet in these products. A little bit of troubleshooting. Again, my audience here is if any of the VFD startup techs are listening in, or any controls folks. Here's some basic troubleshooting items. Not going to go into it real in depth, mainly just to let you know these tools exist. So wiring issues by far, and I touched on this a little bit earlier, account for most of the strange issues where somebody says, hey, it just isn't communicating at all, or it keeps dropping off line every once in a while. It's usually wiring practices related. They went and put the low voltage BACnet wires next to the high voltage motor wires, and then noise got induced, and then problems happen. That's the most common problem. There are some basic things during setup that can happen. So let's say I got that BACnet MSTP where I got those 2 wires, the plus and the minus. Every once in a while, somebody flips those around. Hey, it's humans, we make mistakes. So swapped wires. Sometimes I might have accidentally named 2 devices the same name. So I got duplicate addresses, so I gave 2 drives the same address number. Sometimes one drive might be talking faster than another. Those are all different things that could be going on. So there's actually a parameter in the ACH580 that really is kind of a really cool cheat sheet where it will tell you what it thinks is the problem. So I could scroll to parameter 5807, and if I see my bit 4 is high, oh, I think it looks like my plus and minus, my A and B wires are swapped around. So it really helps streamline some of that troubleshooting. When you do have intermittent noise issues, other than just wiring practice itself, drives do have filters in them to clean up noise. They're known as EMC filters, or RFI, radio frequency interference filters also. So there's screws that you can install to enable them. Also, running that third wire, that reference wire, is just so important when it comes to drives. Whether it's an ABB drive or anybody's drive, that third wire is key. If it's a noise issue that only happens when the drive starts to run, well, shoot, then it's probably a wiring practice that involves the motor cables, because that's when the motor cables start getting all the power going through them. There are other counters available in the drive. It happens to be in group 58 of the drive, so CRC, errors, UART, OK messages. So those are, if you're an old school technician, you already know what those are, and those can kind of help troubleshoot what the core problem is. Well, there we go. We covered everything I wanted to cover in this kind of a BACnet 101 introduction to BACnet from a VFD's perspective. There's a lot of different ways to teach BACnet. I didn't do the controller to controller conversation. I started more and focused at the drive, an end device level piece of equipment, and show how you can pull information from that drive, the value of that information. But really, as we wrap things up, I always like to pose the question, why use BACnet? If you feel comfortable being able to answer that question, it means you got a really good, you've dipped your toe into the water on BACnet, you've got that very good first understanding of BACnet. So let's go through it together. Why use BACnet? Well, it supports a flexible building automation system, so you're not locked into any particular vendor, which really allows you to future-proof your building. You can use any products in the future. Heck, BACnet itself is continuously evolving. Newer products will support newer revisions of BACnet. That's part of that PIC statement. So your building is really future-proof if you standardize on BACnet. If you're standardizing on some proprietary protocol, you're really going to be limited, and if that company goes away or they decide to abandon that proprietary protocol, you might be in a tough spot on how you want to handle updating your building in the future. There's an incredible amount of information that can be pulled from all different types of HVAC products and then displayed in a really cool, user-friendly way on those operator workstations, so you can really understand what condition your building is in. You can tunnel down to drives or systems and see exactly what's going on in different products. And then if you really look at all these different products that are in an HVAC system, the smart products already have BACnet built into them. So you just know that BACnet is the protocol of the past and the future for HVAC, just when you look at how many different products have BACnet built into them. And then lastly, it's not tough to set this up. Granted, the controls contractors and the VFD startup techs for VFDs, as the example earlier, will be the one doing the programming. It is not complex. It is not hard to set up this equipment for BACnet. So there really shouldn't be any excuses not to use BACnet. The cost is not high. The setup is not high. It's just a very friendly protocol that can pull a lot of information from products, bring it to you on your operator workstation, and allow you to see exactly how the building is operating for your HVAC equipment. I've also mentioned HVAC a lot. BACnet isn't just HVAC. BACnet is really being leveraged a lot in lighting and other aspects to your building. So as I talked about VFDs and HVAC, that was just my example I was using today. Keep in mind BACnet is in other places you're building, such as lighting. So with that, I'd like to thank everybody for watching the presentation. Thank you.